Okay, let's start where we left off in the last video. We were doing statistics for paper 2, and this is basically a continuation. Um, so this question says the table summarizes the time M hours that each student in a year group spent listening to music in one day. Some of the results are shown on the histogram. So the only thing that I notice about this histogram is that the classes are slightly, more compact. Okay, let's see what it says. Some of the results are given in the histogram. Use the histogram to find the value of P. Now, what is P? P is the frequency. And what am I given for this bar? This is the bar stretching from 1.5 to 2. So it's this bar. It has a frequency density of 30. So FD, if I were to create a column for this, is 30. How do I calculate frequency density? I know that frequency density is basically frequency divided by the class width. Okay. What is frequency? I don't know that. Let's call that P because that's what it's called. Class width. So the class width is 2 minus 1.5 is 0.5. So I can say that the class width is 0.5. The frequency density is, according to the bar, that's 30. So 30 into 0.5, P is therefore 15. Okay, it's just reversing the process. Then it says complete the histogram. So I'm going to need the class width for all of these bars. 0.5, 0.5, this is class width. It's upper boundary minus lower boundary. Okay, this one isn't 0.5. This one is 1. 3.5 minus 2.5. 5 minus 3.5 is 1.5. 7 minus 5 is 2. So I have to be careful when I draw it because the bars are very different from each other. Okay. For the frequency density, again, frequency divided by the class width. So 14 divided by 0.5 will give me 28. 23 divided by 1 will give me 23. 18 divided by 1.5 should give me 12. And 12 divided by 2 will give me 6. So completing this histogram, then I have to draw a bar from 2 to 2.5 and it should have a height of 28. Okay, that's 27.5, that's 28. That's where I start the bar from and I go up to 2.5. So I'm going to take this and try to draw it. I have to shrink it a little. Okay, yep. And that is the first bar. Okay, then I have 2.5 to 3.5 and the height has to be 23. So that is 23. Okay, and then 3.5 to 5 and that is 12. So 12 is here, just a notch below 12.5 up till 5. It's 5, yeah. Okay, and then 5 to 7 is 6. So that's 6. Okay, this bar is slightly shorter. Okay, so that is the other part. So that's the complete histogram. Make sure that you show your working. Don't just rush through the question and rush to a final answer. Okay. This table summarizes the time hours that each student in a group of 50 students spent cooking in 1 week. Okay, calculate an estimate of the mean cooking time. So the mean is again sum of fx over sum of f. We have done this before. Sum of f is simply 50. Okay, that has to be 50 because that's how many students who were surveyed. Okay, for x I need the midpoint of these classes. So 0 and 2 will have a midpoint of 1, 2 and 4 will have a midpoint of 3, 4 and 6 will have a midpoint of 5, 6 and 8 will be 7, and 8 and 10 will be 9. So I'm going to say that this is 1 into 8 plus 3 into 16 plus 5 into 15 plus 7 into 7 plus 9 into 4 divided by 50. Okay, let's quickly put that on a calculator. $4.32. Okay, let's check if that is the final correct answer. I just want to be absolutely sure. Correct histogram and 4.32. Okay. Then it goes on and says that we need to draw the cumulative frequency diagram. So again, I use the upper class boundaries only, and I will need a cumulative frequency. So I'm going to add up 8 plus 16 is 24, 24 plus 15 is 39, 39 plus 7 is 46, and then 50 at the end. Okay. Okay, so 2 and 8 mark across, 4 and 24, 5 and 39, 7 and 46. No, not 5 and 39, it's 6 and 39. That's what I was wondering. Okay, 6 and 39, 8 and 46, and 10 and 50. Okay, that looks like a relatively simple one. I'm going to join this to 0 at the end. Okay, that's as smooth as I could make it. Then it says estimate the median, so that's going to be the 25th value, half of the 50th. 25th. So where is the 25th then? Okay, let's try to read it as accurately as possible. Always draw this dotted line because it helps you read the graph. I think my graph is a little crooked here, so I'm going to try to draw it again. That is a tough one. Okay, now it seems reasonable. Okay, let's read on what we have on 25. So this looks about a little above 4. So that's between 4 and 5. So one of these boxes is 0.2. So half of the box should be 0.1. So I'm going to say 4.1. That's my gut feeling. Let's just check what the range is so that we fit right into it. It says between 4 and 4.2. So I'm very accurate. I'm right at the middle. So that's the correct answer then. Okay, that's the end of this question. This question is also from the same paper, the one at the bottom, but it is from a different part. I don't know what question this is, but it's supposed to be a question later on. It's the same paper, May June 2020 2-2. It says Rohan throws the dice 200 times. The bar chart shows us the result. So you see a bar chart is drawn. Remember that whenever you're drawing a bar chart, the labels have to be in the middle. That is what I explained in another video as well. So you can look at that. Use the bar chart to complete the table of results. So I just need to read the frequencies. Let's try to read the frequency of the bar at 4. Okay, so it's in the middle, so that's 35, I think. Then 5 is 22, and 6 is at 38. As viewing around the result, find the relative frequency that he threw a number less than 3. Okay, how many tries did he take? 200 times, so the denominator is going to be 200. Less than 3, how many are less than 3? That's 31 and 46. So 31 plus 46. What's 31 plus 46? Divide by 200. That gives me 0.385 is the relative frequency. Rohan says that the dice he has thrown is not a fair dice. Make 2 comments to explain why the dice may not be fair. Okay, so there are 2 comments that I can. Okay, so there are 2 comments that I need to make on this situation. One is that one is regarding the experiment. Okay, whenever we are trying to do something like this, it's important to take a large sample. So it's important that I have a large sample. So I go back and see I have taken about 200 times. So that means that my probability should actually be in reality the same as what you would expect on a fair dice. For a fair dice, you have the probability 1, 6, 1, 6, 1, 6, 1, 6 for each number. So given that I have a large sample, yes, this experiment is a good way of determining whether the dice is fair or not. One is that it's a large sample. The other thing that I see is that 1 has a very high probability. 1 has the probability 46 over 200, which is higher than 1/6. Okay, or you could also say that this lowest number 5 has the lowest probability, so this die is biased sort of more towards 1 than towards 5. The others seem to be relatively equal, but again there is 3 which has another probability. You see, you cannot expect the probability to be 1/6 in such an experiment, but it has to be closer to 1/6. If I try out 46 divided by 200, it comes out to be about 0.23. 1/6 is 0.17, so 0.23 and 0.17 are very far apart, which is why these are the 2 reasons why this die may not be fair, and this experiment is a good way of determining that. Okay, moving on to the next question then. I have this. It says the cumulative frequency graph shows the masses in potatoes in grams of potatoes of variety A. Use the diagram to estimate the median. Okay, so how many potatoes do I have? 60, so that's half of the 60th, 30th. So let's quickly go on and check on the 30th. Now, since this diagram is drawn, there will be probably no margin for error when you are reading this. You have to be pinpoint precise on what number you are reading off the grid. So I'm reading 188 off the grid. Okay, so that's the median. For the interquartile range, I'll need the lower quartile, which is 1/4 of the data. Okay, so what is 1/4? That's the 15th observation. So I'm going to go on and read the 15th observation. Now again, it's going to be somewhere in the middle of these two. I'm going to try to be as accurate as possible. I'm coming on to this number, and that's 170. So that's 170. That's the lower quartile. Then for the upper quartile, I'll need 3/4 of the data. 45th. $208. So what's the interquartile range? 38. Okay, potatoes with a mass greater than 220 grams are sold as baking potatoes. Find the percentage of potatoes that are sold as baking potatoes. So greater than 220 grams. So what I'm going to have to do is go back and read my graph. It's 52 above 220 grams, right? A mass greater than above. So how many are above that? 8 out of 60 multiplied by 100. So that's about 13.3%. Let's check if that's the correct answer. Looks a little odd. I want to be absolutely sure. I know there's a functions question here. Where is that question? It's 2A1, 2A2, 2A2. 2A2. Okay, the answer is missing from here, but the working is correct. That's weird. Okay, the masses of 60 potatoes of variety B are also measured. For variety B, the median is 175. Okay, this one had a median of 188. Okay, let's check the median as well before we compare it improperly. 188 and 37 to 39. So yes, I have both answers are correct. Okay, 175 grams and interquartile range is 30 grams. Okay, Kali wants to buy potatoes that are more consistent in mass. So what I mean by consistent? That they do not vary a lot. So they're closer to the center as such. So what is the center in this case? The center is the median. That's the 50th percentile. So I want them to be close to the center. So when will they be close to the center? When the range is lower. So should she choose variety A or B? She should choose the one that has a lower range. In this case, you've calculated the interquartile range. So you compare the interquartile range. You'll say variety B because it has lower interquartile range. Okay, then moving on, the table shows the masses m grams of 120 potatoes of variety C. Calculate an estimate of the mean mass. Okay, so sum of fx over sum of f. I'll have to write down the x, midpoints 90, 110, 125, 135, and 148, 200. Okay, 170. So this is going to be 90 into 10 plus 110 into 15 plus 125 into 42 plus 135 into 36 plus 170 into 17 divided by 120. $129.583. So that's one. If I round that off, it becomes 130. Through three significant figures. Okay, let's just check. 130. Okay. Now there's a bag of potatoes has mass 2.5. Correct to the nearest 100. A bag of potatoes is this. The mass of the box of is 600 grams. Correct to the nearest 10 grams. Calculate the upper bound of the total mass in kilograms of a box containing 10 of these bags of potatoes. So this question is about approximation. So I'm going to skip that for now. That's a question for later on. Although it's a question that you should do because it's 3 marks. You should be able to calculate upper bounds and lower bounds. Okay, moving on quickly to the next question that I have here. Okay, this one is a counterpart cumulative frequency. Let's see if it has something different. It doesn't have anything different, so I would rather skip that. The one thing that I would want to tell you is that when you join this graph, you join it from 0 to 20 and then sort of draw whatever points are there and make an S-shaped curve. Okay, this is also pretty simple, nothing very strange about it. Probability questions there. Let's see if we have something more interesting. Okay, this one has a pie chart, so I'm going to do this. It says the table shows the number of exercise classes attended in 1 week by each of 80 members of a gym. Find the mode. Okay, what is the mode? It's the most frequent observation. So which one has the highest frequency? This one has the highest frequency. So the mode is 1. It's not 29, it's 1. It's the corresponding value of x. Then the median. So I'm going to say that it is half of 80 plus 1 th. That gives me 40.5. So I'm looking for the 40th and the 41st observations. 40th and 41st observation. So I start adding 10 plus 29, 39. The 40th and the 41st observation are both in this category, which means that both are 2. So I can confidently say that the median is going to be 2. Then says a pie chart is drawn to represent this information. Calculate the angle representing 5 classes attended. So what we need to remember is that when you're drawing a pie chart, the angle corresponds to the frequency. So the entire angle will be 360 and the frequency will be 80 because 80 people attended. Okay, calculate the angle representing 5 classes attended. So what was the class? 5 classes attended had a frequency of 2. So I'm going to say 2 and x, and then I cross multiply and solve. So 360 divided by, multiply by 2 divided by 80. About 9 degrees, I think. Yeah, 9 degrees. Okay, so I'm going to write 9 degrees. Okay. Then this is another question on a histogram. This time the histogram is drawn for you. What does it say? It says 30 members spend time between 30 and 60. So the frequency here is 30. It says 30 members. Okay. Okay. So calculate the number of members surveyed. It's asking you for the total frequency of all the categories, right? It is a 3-mark question, which means that what you have to do is you have to calculate all the frequencies, do a backward sort of calculation. So whenever you have a question like this, it's best to, first write down your classes. 0 to 30 is the first class. I'm going to write that here so that you can see it clearly. 0 to 30, then I have 30 to 60. There's going to be a question column for FD, and there's going to be a for frequency as well. This frequency is 30. It had an FD of 1. Okay. This one had an FD of 0.6. I'm going to write that too. Okay. Then it's somewhere between 60 and 90. So where can I imagine it being between 60 and 90? I'm going to say 60 to 75. And it has a frequency density of about 4.4. Okay. And then the last, then there's 75 to 90, which has a frequency density of about 1.6. And this one has 0.4, I think. Yeah, 90 to 120, 0.4. So how do I calculate the frequency? I know that frequency density is frequency divided by the class width. So what I need to do is I need to multiply class width with the frequency density. So what's the class width for the first one? I can obviously see that it's 30 minus 0, that's 30. So I'm going to multiply 0.6 by 30. What do I get? I get 18. Then the next class width is 75 minus 60, that's 15. I'm going to multiply it with its frequency density, that's 4.4. So I'm going to get 66. Okay, you can also have a column for class width if you want. You can write down the class width 30, 30, 15, 15, and then 30. Okay, 15 into 1.6 gives me 24. 30 into 0.4 gives me 12. $150. Okay, so 150 people. Then it says Rohit says 1/10 of the members spent longer than 1.5 hours at the gym on their last visit. Is he correct? Okay. So longer than 1.5 hours. 1.5 hours means 90 minutes. Okay, so how many people spend more than 90 minutes? There were 12 people. He says 1/10 of those of the members. So let's calculate. Okay, so if I were to take 1/10 of 150. That gives me 15. From my experience, I know that only 12 members spent more than 1.5 hours. So no, he is not correct, because a lesser number of members spent more than 1.5 hours. Okay, let's check if that answer is correct. 1/10 is 15 and 12 spent more than 90 minutes, so he's wrong. Yeah, that's what he said. Okay, and another question in pie charts. It says the pie chart summarizes the ages of people at a science fair. Write down the model class. Remember that the model class is the one with the highest frequency. Now in a pie chart, it's obvious that even if you don't have the frequencies correspond to the angles. So the one with the largest angle should have the largest frequency as well. So that's the largest angle. So I'm going to say that the model class is 16 to 20. And says there were 90 people aged over 30. Okay, so that's there. So that frequency is 90. Calculate the number of people 16 to 20. Okay, so I can just then again make my ratios angle to frequency. I can say that 54, an angle of 54 corresponds to 90, and angle of 144 should correspond to what? Okay, and then what I simply do is I cross multiply. I can say that 54x equals to 90 into 144. So 90 into 144 divided by 54. It's 240. Sounds like a reasonable answer. Why? Because it had to be a whole number. Because it's frequency. Okay, that's 2a. I think that's a continuation. Yeah. Let's move on to the next question. Again, completing a histogram. Okay, then there's something, so I'll complete the histogram quickly and then sort of move on from there. Again, I need the class widths, so I'm going to say 40, 20, 10, 10, and 20. What bars are drawn for me? Just the 70 to 80 bar is drawn for me, so I can leave that one out, and I can calculate the rest of the frequency densities. Now remember, frequency divided by class width, don't divide it in the other way. It's going to give you wrong answers, so that gives me 0.9. 48 divided by 20 gives me 2.4, 6.4, 2.1. Okay, then 60 to 76.4. It's a relatively high one. Okay, and 70 to 80 is already done. 80 to 100 is 2.1. Okay, then there's students who scored 75 or more were awarded a distinction. So 75 or more. You see, my class doesn't have any 75, it just has between 70 and 80, so I'll have to be a bit careful about this. It says find an estimate for the percentage of the 250 students. There were a total of 250 students. Okay, so can I say that this class could be divided into half? Let's say this class would become 70 to 75 and this would become 75 to 80. 5 people would be here, 30 people would be here and 30 people would be here. Why? Because there were a total of 60 people. Now, how many are more than 75? See, I'm estimating. Now, this is not a precise answer. Why? Because I've divided the class sort of on an average basis. Okay. But that's what the question is asking you to do. It's asking you for an estimate. So 72 out of 250. So let's calculate that percentage. 72 divided by 250. It's 0.288 into 100 is 28.8. Let's verify if our answer is correct. This is B2. Yeah, we got 28.8. Correct histogram, 16 to 40 and so on. Okay, so all our answers are correct. Let's see what more questions we have. This is about a histogram. I think that's simple. Let's try to do this one. It says Yasser wants to starts work each day at 9 a.m. Okay, Yasser records the length of time he spends on each work of 70 work days. The table shows the result. Okay, so 4 to 6 and 6 to 7 and so on. Okay, then he says he starts at 9 a.m. He is paid overtime if he works later at a time later than 5:15 p.m. That means how many hours is this? This is about 8 hours and 15 minutes. If he spends more than 8 hours and 15 minutes, that's about 8.25 hours. So I can say that up till here, I don't have that. Okay. That's quarter of an hour. Okay. Estimate the number of days he's paid overtime during these 70 work days. Again, this question is asking you to do what? It's asking you to break up this class into a class from now. I hope everybody understands that 15 minutes means 1/4, 1/4 of an hour. So can I sort of divide this into 1/4? That's 8:15, and the other one from 8:15 to 8:45. Okay, so that's a disproportionate class, 15 minutes here and 30 minutes there. That means the ratio has to be 1:2. If I split this quantity 18 into a ratio 1:2, I'm going to get 6 and I'm going to get 12 here. Or I could split it into 3/4, say that 666 and 666 and do that as well. But I need to calculate the days that he gets overtime here. So 12 days here and 10 days here, that's a total of 22 days. So I'm splitting up classes into equal sort of widths so that I can estimate what frequency lies in each category. That's something that you are expected to do on the exam as well. Okay, where is my answer? That's 22. Yeah, that's the correct answer. Okay, this question is simple. It's a simple mean question. This one is about cumulative frequency and I need to do it in reverse. So we're going to do this as the last question, maybe for today. I'll have to go and see if we have more interesting questions later on. I don't think we do. We could do this and make two comparisons as well. Okay, let's do that as the last question. Let's first try to do this. It says a group of adults also completed this table. Okay, it has first part. Okay, a group of students complete the table, number of students, mean number of students, and so on. I hope there's not a comparison. Okay. Let's do this frequency. This is about adults then. That was about children. This is about adults. Let's use the cumulative frequency to complete the frequency table below. Now this is tricky. Remember that what you're trying to do is you're trying to look at your classes. So at 100, you would have plotted 100, 8. So that quantity is 8, right? Okay, so I'm going to mark each of the classes and then the quantity. So the next number that you would have plotted is 150 and its cumulative frequency. So what have you added to this? Let's try to read from our diagram first. This number is 30. So how much have I added? I've added 22. So this class must have been 22. Then I go on to 200. and try to read this class. Okay, it was a little tough to read, but 66. So what would I have added? I would have added 36 to this, then 250. That's high up. Let's just go like that. That's about 112. So what's 112 minus 66? It's 46. I've added 46, and that last one is 120, so 46, and then 112 minus 120 is 8. Okay, just to be sure, I'm going to add up all the frequencies and see if they add up to 120. So to see if I've done my question correctly. Yes, they add up to 120, which means that I've written down the frequencies correctly. Use the cumulative frequencies diagram to find an estimate of the median. So the median is going to be the 60th value. I think that's obvious right now. So I'm just going to go back and go on and read that value. It comes up a little before 200. How much is one box? Oh, that's 50 boxes. So 195. Distance of 50, so 195. Okay. Then it says 55% of the adults took between 125 seconds and k seconds to complete the puzzle. Use the cumulative frequency for diagram to find the value of k between 125 and k. So where is 125 going to be? That's going to be 125. Okay, and erase the rest of the working from the diagram so that I can see my numbers clearly now instead of messing them up. Okay, so let's draw that with a different color. So that's 125. So 55% of the adults took between 125 and k seconds. Now I don't need know the upper boundary, but I know that what I want is that I want two boundaries. One of them is that's 18. What's 55%? 55% of the total. So 55% of 120. What does that give me? My calculator tells me that gives me 66. So what I want is wherever the next boundary is, the number of people between 18 and that number should be 66. So what I'm going to do is I'm going to add 18 and 66. So I need to be at 84. So I'm going to say that if I want 66 people to be here, I need that top boundary to be at 84. So where is that top boundary at 84? I'm going to go down and read it. And one of these boxes is 5, so 10 and 15, 215. I'm going to say that k is 215, so that when you draw two boundaries from 215 and from 125, there are 66 people, and 66 people is basically 55% of the total. Okay, I hope I've done that correctly. I'm trying to find which one is the answer. 22 to 36. Okay, 5v2. I think I'm missing out the answer here, so I think that should be correct. The median is correct. Okay, so get the next question. Fairly simple. I'm not going on and doing that. Let's see for more interesting questions. Okay, let's look at this. It says Marco grows two types of tomatoes plants, type A and type B. He counts the number of tomatoes growing on each tomato plant. The result for type A plants is shown in the table. Calculate the mean. So the mean you already know is sum of fx over sum of f. Okay, so I'm just going to multiply and write the totals for you. 17 into 5, 18 into 2, 19 into 7, 20 into 3, 21 into 2, and 22 into 1. 378. Okay, what is the total number of plants? Oh, surprisingly that's not given. So 5 plus 2 plus 7 plus 3 plus 2 plus 1. 20. 17.9. Okay, calculate the range. So the range is the highest value minus the lowest value. So the number of tomatoes on plant, on the highest number was 22, the lowest was 17. So I'm going to say that it's 22 minus 17, and that's 5. Okay, the mean number of tomatoes per plant for type B plants is 17.1. So the mean for the other tomatoes is lower, and the range is 8. So it has a wider range, though it has a lower mean but a wider range. Make two comments comparing the number of tomatoes growing on type A and type B. So the two comments that you usually make is one on the average. So the average number of tomatoes for type A is relatively higher than type B. But since the range is higher, I can say that the data for type B is more spread out than data for type A. Okay, let's check if those are the correct numbers that you should correct comments that you should have. This type A has more tomatoes per plant, that is based on mean. Follow through their mean and range. Okay, number of potatoes per plant is more consistent for type A or equivalent. So equivalent means the same. So the idea is, what I've seen a trend in this is that when it says, when you're comparing the range, the idea is to use the word of consistency or spread of data. That's what I've used. Okay. Uh, Okay, type A has more tomatoes per plant. So I've written the average number of tomatoes per plant is more for type A. And that's the same thing. Okay, I hope this session was productive. Please make sure to like and subscribe for more topics. I will be back with more videos. Thank you.